Denis, lovely to meet you. Thank you very much for allowing me to have a look around this incredible place. Can you give me a little bit of background as to how you managed to, I don't know, get the funding, build this wonderful, fantastic new facility?
Yeah, well, it's great to hear that you enjoyed coming here and you were impressed by it, because we're impressed by it as well.
Very impressed.
I think one of the key points to get across is this is not just one person, it's not just me.
Okay,
it's a whole team of people, some of whom you've already met. But also it builds on quite a history of research at Birkbeck into child development and into learning. So maybe if I step back a little bit, this facility, the Toddler Lab, is part of a broader umbrella organization called the Center for Brain and Cognitive Development.
Okay.
And this has been around for almost 25 years now. And the mission of this center is to kind of try to understand the relationship between what's happening in young children in terms of brain development and how this explains what they can learn at certain ages and what they can't learn and why it might sometimes go wrong or follow an atypical path and so forth. And as part of this center, which kind of really involves a broad look at that learning and cognition in, say, typically developing children and atypically developing children as well, we had a lab called the Baby Lab, in which we focused on under twos and trying to record brain activity in under twos babies while they were learning physical things about the world, relationship between objects, maybe faces, the link between a face and its emotion, and maybe learning early language as well. And the technology we had for doing that was ideal for studying infants, because we might put, say, some kind of hairnet or a cap that would have sensors that would record the activity, but this cap and hairnet would then be plugged into a giant amplifier in the wall. And as you well know, young babies don't move around very much. So, if they're happy to cooperate, they'll just sit there, take part in your experiments, and we can happily record brain activity. But something dramatic happens from about 16 months onward, and that's the fact that they want to move around.
Mobility.
Absolutely, yeah. Mobility. And it's not just that they lose patience with sitting there and being plugged into something. So when we tried our old-fashioned methods on these kind of walking or mobile toddlers, they would just rip everything off and move on. It's not just that they don't like it, but it's that their natural behaviors involve exploring things physically around or moving around, starting to interact with their peers, to learn things with and from their peers as well. And by plugging them into, sitting them into a chair, plugging them into the wall, we were really limiting their ability to demonstrate how they learnt about things. So the idea of this kind of Toddler Lab came out of the need to expand the Baby Lab in order to capture all this kind of mobility-based learning that we observed in slightly older kids. Plus, this was coupled with the advent of new technologies, smaller kind of amplifiers, wireless and wearable technologies. That meant that we didn't have to have these kind of recording caps recorded into a wall anymore. The caps could have a little transmitter that would then transmit to a computer that was either based in another room or here. And
so more naturalistic. You've managed to create
more naturalistic in terms of the movements, but then on top of that, what we've done in this building is really create environments that reflected natural environments in the child's real world. So here we are sitting in homeroom environment. This is a laboratory with motion capture cameras and brain recording equipment set up to be like a typical front room, where you might have some television sets, you might have some siblings playing in the background while you're trying to learn something, noise from the street and so forth that would be kind of interfering or maybe bolstering your ability to learn certain things. Similarly, on another floor, we have the preschool lab, which is set up to look like a nursery school for 3-year-olds. Here, we will be able to bring in groups of children with a teacher, for example, and then look at how the children develop learning together in cooperation, guided by the teacher, and how this is reflected by changes in their kind of brain activity, and perhaps even look at particular traits of the kind of teacher-child's brain activities that may predict or support kind of better learning, more effective teaching, and so
caps
forth.
On teachers as well.
Caps on teachers as well. So a really fascinating finding that's come out recently is that when individuals are working together, they tend to first move in synchrony at small levels. They're not aware of it. They might be shaking their heads at the same time and so forth, as we are doing now. Exactly. But actually, if you record their brain activity, you get evidence of synchronization occurring between the activity of the individuals that are working together. Now, this doesn't mean that we're tapping into some kind of ESP or some extrasensory perception or anything like that, but rather that they're focusing on the same task jointly. And part of what we're hoping to do in the preschool lab is look at the emergence of this kind of synchrony across individuals in young children as they move from playing in parallel with Lego, for example, to playing together collaboratively, and then moving on to kind of working together collaboratively to solve problems. So does synchrony arise? What ages does it arise, and how does this predict or help facilitate the kind of collaborative work and problem solving?
Fascinating stuff. And you have a cave downstairs. It's an amazing place.
We do have the cave.
Tell us a bit more about the cave and the ideas behind that one. Why did you put that in?
So I talked about naturalistic environments. We have a homeroom environment. We have the preschool environment. We actually also have a nap lab where children can go to sleep and we can do brain recordings while they're sleeping. And those are great, but they are limited to 3 different environments. The cave is an immersive virtual reality environment that will therefore allow us to transport children virtually into any setting whatsoever. So again, if we're looking at peer interactions, we could transport children. We could have more than one preschooler or toddler in the cave. We could transport the children virtually into a playground scene or a forest scene or a beach scene and see how the different context can help them, and their familiarity with those contexts might help them collaborate or cooperate better or learn about certain types of natural science domains, such as the beach scene or a forest scene and so forth in different ways. So really the world is our oyster in terms of that.
I was going to say the opportunities are vast.
Absolutely.
Are you, I was going to sort of go longitudinal. You're moving from baby lab, toddler here. Beyond, do we stay here? You stop at sort of 8, 9, do you? Or
the benefit of having this toddler lab, here we're using the word toddler very broadly.
Right,
it's from basically 2 to 6, let's say, so preschoolers as well. So again, the benefit is that we can continue, not only do we have the kind of naturalistic free roaming environments, but we can of course continue to follow individuals that came as babies, up until 5 or 6 years of age. The facilities could potentially be used for older ages, but that's not the plan at the moment. If we run out of ideas of things to do with 4-year-olds, then we may move on to older children.
Hi, Lisanna. Thank you very much for showing me around this wonderful, wonderful lab that you've got here. Can you just explain a little bit about what you do here?
So I work as postdoctoral researcher, and before I did my PhD here as well. So I just, I think about questions, about things we want to investigate, and I design an experiment, test kits, analyze the data, and then write a report or talk about, what we find.
So earlier today, for example, you had, I think it was a 4-year-old that was in this particular room, and you were getting them to do stuff. What were you looking at there?
So I'm interested in complex action planning in that kind of study. So for example, imagine you're waking up in the morning and you're kind of making your cup of coffee. So we string together several actions to achieve making the cup of coffee.
So when you say the several actions, you had them wearing gloves, I believe.
Yeah.
They were wearing a cap.
The cap
they had
as
a
well.
Backpack
Yes.
And then they were watching a video, being asked to take bricks out of boxes. So that's putting an awful lot of information in front of them and analysing all of that.
Yeah, so we're interested in kind of whether they're able to achieve a goal with stringing together several actions. So we'll ask them to build a house for Bob with multiple Duplo blocks.
Oh yeah, Bob was
the Bob was the little Duplo man there. So basically they have to build one wall, which is kind of a sub-goal, and then they build another wall and a third and a fourth wall and put on the roof to kind of achieve the goal of building a house for Bob. And that's kind of also the movie is there to provide them guidance on how to build the house. And then also we measure their movement. So we have the little cycling gloves, which are I think also on the table. So we can track their movements and we can kind of see how they're moving. And we think that especially at kind of decision points, so when, for example, you finish the yellow wall, but now we need to switch to making a blue wall, like you making coffee and you added milk, but now we need to think again, do we need to add sugar? So we can get kind of these decision points, their movements might be different, and we're kind of using that the motion capture to take a look at that.
So you've got cameras
Yeah,
all
it's
around,
all around
it,
the
and
room,
they're
yes.
watching what
Yeah.
happens with.
Yeah.
Okay, and that then goes into the computer,
Yes.
as does the head stuff.
Yeah, the head.
That's
So
brain
yeah.
stuff.
Yeah, so we're
Okay.
also interested in which areas are kind of more active. You know, especially when you pause again, you're finished your yellow wall, you need to start your blue wall. Yes.
And once that's all been done,
Mm-hmm.
you're then going to be doing this, following this particular toddler through on a longitudinal study, or will you just be trying to get a lot of other toddlers?
Yeah, so at the moment we test several age groups. So we test 3 and 4 and 5-year-olds, and we kind of see the improvements over age. So we can see, for example, that a 5-year-old will be more likely to be successful at building a house compared to a 3-year-old, because it's quite difficult if you're 3. So yeah, and we're trying to also relate kind of their movement development, but also their brain development to kind of how they improve.
Which is absolutely fascinating. But I'm a bit of a layperson, so, and I'm also a teacher. So can you see how this could be applied to what's going on in a preschool or a year 1 classroom, a primary school classroom here, or kindergarten maybe abroad?
I mean, it will give us some understanding of like what can kids do and what is too difficult. Like, for example, should you instruct your 3-year-olds when you want to go outside? Should you say, we're going outside? Or maybe it's better to say, put on your shoes, put on your coat, kind of sequencing it instead of assuming that they're able to achieve the whole sequence. To kind of provide better understanding.
Is that like a working memory thing, or are we moving beyond the working memory?
So I think it's even beyond working memory. Like, working memory is very important, right? We also have a working memory task. So as you saw when we were here, the girl was trying to remember all the numbers Fluffy said and said it backwards as well. So we think working memory is important, right? You have to remember the goal, but then you also have to take your own actions and plan your own actions to achieve the goal.
Very, very interesting. So this place looks so well kitted out. I'm assuming that you are very excited about working here, and you're going to stay here for your entire career, because there seems to be so much that you can do here.
Yeah, I mean, it's amazing. Like, we can have toddlers moving around. You know, they wear
Really?
the backpack.
Because of
We
course
can,
they've got
the
a
backpack, so they can do anything they like. They can be more naturalistic. Like, we used to have to measure them. You know, they have to sit still in a lab, but now we can actually look at behavior that happens in daily life. You know, when planning a complex action with Duplo blocks, but also, you know, when interacting with another person and stuff. Yeah, so it's very amazing.
So your own brain must be buzzing with opportunities
Yeah,
of what it is that you'd like to do.
I think we have way too many ideas for the time we
almost
have.
do.
Yeah.
So you could have almost a classroom set
Yeah.
up here with a.
I think that's the
a
idea.
member
In
staff,
in a
so to
few
speak.
years, yeah, that would be amazing. That we have kids in a
Why do
classroom.
you have to wait
and
a few years?
I mean, we have to determine on the analyzing methods as well, because, you know, it's
Okay.
not been done often. So, like, especially, for example, the FNIRS, which we talked about with the near-infrared light.
That's the cap.
Yeah, that's the
Yeah.
cap. Kind of, if you move, like, it does in fact impact the data a little bit, so we have to find the right way how to deal with that, and that's easier with, you know, a study where they still sit on a chair but they still move a little bit. But, you know, once we put in a multiple preschool kids, they will start running around, and of course we first need to make sure that we can actually analyze that data before we collect it. But
And the young person, do I call them toddlers? The young
Toddlers,
person.
yeah.
The young person.
yes,
She seemed incredibly happy here.
yeah,
She was holding your hand and wanted you to go and play elsewhere. So I'm very impressed with that.
yeah.
So what can teachers do? I presume you need parents and toddlers to
Yeah.
come along and willingly participate in your interesting research.
Yeah, so we're always looking for more parents that want to participate with their children. So we can sign up on our website, and then you get into a database, and basically if your child is in the right age, we'll be in touch, and then if it works out, you can come in. I mean, if you're too busy, of course, we understand. But we're also looking for schools, so sometimes we have more tablet-based tasks or something more behavioral, and we sometimes test that in schools. So we're also looking for schools that are willing to participate in research.
So this is the sort of the
Yeah.
other bit of
The
what's
other
going
bit
on
of what
in
we
the-
do,
in the
yeah,
whole of the
yeah,
Toddler Lab.
yeah.
Absolutely fascinating,
Yeah.
and thank you very much for showing me around today. I've
Yeah,
had a
thank you for
fantastic
coming,
day.
yeah.
It's a lovely, wonderful place. You must be so excited about the future.
Yes, it's very exciting.
Wonderful. Thank you very
Thank
much.
So I'm Jacob, I'm a veterinarian. I'm the father of Ida, who is visiting the Toddler Lab today. She was invited to participate in studies,
Okay.
and she always enjoys coming here, so we try to best to support her.
Your own personal involvement, you quite like the idea of getting involved in research because you can see that actually in the long run these are going to be producing results, data that could be used in an applied way in schools,
Yeah.
in preschools.
I think so. I think the ultimate goal is to understand how toddlers develop. So at least this is my understanding of it, and I think that could be quite beneficial for our society to get to know how do toddlers learn and how can we support them in learning. Also, for example, if they do these movement studies, how do children move? Could we maybe adapt the children's environment so that they progress? And yeah, so I think it's very important to support the scientists in doing that.
Wonderful. Well, fascinating stuff. Lovely to meet you, Jacob. Absolutely fantastic.
Thank you,
Thank you very
Jeremy.
much for getting involved in the Toddler Lab.
Thank you very much as well. Thank you.
Wonderful, wonderful. Hi, Paula. Can you tell me a little bit about what you do here in the Toddler Lab?
Yeah, so I'm the senior lab developer here, so I do work with the technical stuff around the labs. So I work with developing the technologies, the experimental setups for the studies ongoing here, and also work on the software and data analysis development for all the data that we record during our experiments.
I have to say, watching what went on this morning with some of those experiments, there's a lot of data that gets recorded.
It's a lot of data.
And you are responsible for storing it and all
Yeah,
that sort of
storing
stuff.
that, and it's very important to have all these recordings synchronized to each other, so we want to make sure that everything starts at the same point, right?
So when the, dare I call them experiments, but when the pieces of research being undertaken, do you need to be around all of the time, or are you able to flip between the home lab, the toddler lab? You've got a cave at the bottom as well, which is really interesting. Or can you sort of supervise everything?
Yeah, exactly. So I do the development and then train other people, our students, our postdoc, and then they do the experiments and data collection on their own. And then we brainstorm and work together on the data analysis. I work on the programming side of things, and then hand it over, train them, and they go along. And
so can you just take me through as a sort of layperson when you say all of the sort of data stuff? So you have something in your lap here that you're, and I've seen this on a toddler's head. A 4-year-old earlier today had this on their head, and it obviously isn't a crash helmet. So what are you doing with this thing?
yeah, so this is a functional near-infrared spectroscopy device.
Wow.
Yeah, so this is a very
Okay.
exciting piece of neuroimaging kit. So with this
So
device,
when you say neuroimaging, it's able to look
at the brain
partly
activity.
inside my brain?
Exactly.
Okay.
So we're looking at the activity in parts of the brain.
Okay.
And this is an optical technique, so it uses light. So if you look inside this cap,
Oh yes, I can see.
you
So
can
the
see
red
this
light.
red
Yes,
light
yes,
flashing.
Yeah.
So this means that with NIRS, we shine the head with red and near-infrared light, and we look at the absorption of this light by the hemoglobin flowing inside the brain.
So the blood.
The
Right,
blood,
right,
exactly,
right.
the blod
Okay.
flow in the brain. So the assumption is that when a brain region is activated, of course, it needs more oxygen, right? So more fuel to work
Absolutely,
and to
yeah,
support
yeah.
its activity. So this is why we observe an increase in the blood flow in that area of the brain.
Is that why you don't have a full cap? That's why you've got individual light emitting things that are localized, so you can see whether or not something is happening in an area as opposed to another area.
Exactly. So we
Okay.
can identify exactly at which point brain activity is happening at a certain time during the experiment.
And I note that they also had a little backpack. That's where these batteries go?
Exactly. So this is a very new piece of device. So this is fully wearable. So it's very different from the neuroimaging techniques they were used to, like MRI scanners or typical lab-based instrumentation, where we are basically tied and connected to a big piece of
Okay.
instrument behind you. So this is fully wearable. So this is the main unity of the device, which is very lightweight. So the whole thing is around 300 grams.
Fantastic. So they can walk around
Exactly.
almost as if it's perfectly normal.
Exactly.
It's not
You can
absolutely
wear
normal
it.
with that.
Yeah.
I could wear it.
You could wear it as
I'm
well.
not going to, but so it fits
But
on adults as well.
anyone can wear it and walk around and
Wonderful.
move freely.
And then that then connects to the information that you then have here. So this is the sort of data stuff. that
exactly.
you'll be
So
looking
this is the main unit that connects wirelessly to the laptop.
at. Okay.
So with the computer, we record all the data, and then we process them and analyze them after the experiment.
And I also noticed that you put downstairs in the cave and also up here, you'd put some small gloves on
exactly.
the young participants.
Yes. So these
Oh,
are
there they are, yes.
yeah. These are the gloves that we used before.
Right.
So here you can see these reflective markers, these reflective dots. So the special cameras that we have here around the Toddler Lab are able to measure the movement of any part of the bodies.
Oh, wow.
So they're able to track the movements of these reflective dots. So for example, in the experiment you saw here, we were tracking the movements of the head.
The hands, I saw the hands moving, okay.
While the girl was picking up the Duplo blocks, and the same in the cave. So in the cave we use it actually to interact with the virtual world. Right? So in the cave we project virtual scenarios, virtual places, virtual objects.
Yeah, they were participating in a sort of virtual world of games and moving around in a virtual world.
Exactly.
Okay.
So you can use this information to walk around the space, for example, or you can grasp virtual objects, you can throw things, you can interact with the environment, you can move your head. And
you also had a pair of glasses on. Are these the glasses that you had?
Yes, so these are specially designed glasses.
Did you design them?
Yeah, so because one of the issues that we have in research is that most of the technologies, off-the-shelf technologies, are not toddler size.
Oh,
so
right.
they can be too big and too large for them. So what we did
Specially
here...
adapted.
Exactly. So we 3D printed, so we designed it, 3D printed a toddler size glasses that actually, they are very light, but they incorporate a lot of technology.
So these are 3D and this is a camera?
Exactly. So these are lenses that allow you to see in 3D in the cave. And we also have very special cameras here behind the lenses. So these are eye tracking cameras.
Oh, okay. So these things here?
Yeah, these very small things here.
Wow.
They track the movement of your pupil. They track your eye gaze.
Oh, wow.
Yeah, so they track the movement of your pupil.
And these are similar to what's on your gloves,
exactly.
So you can see where the head is going.
So these are the reflective markers that I showed you before, exactly like this one, but we can use them on our headset to track the rotation and the movement of the head.
Wow. You must be very excited about it.
Yeah, it's very excited. So these all cutting edge technologies, and it's all very new and very exciting with lots of development.
So you and your colleagues are working at the moment on designing new experiments.
Exactly.
You're up here, you're in the cave, you're in the home lab as well.
Exactly. So yeah, in the cave we are designing new experiments, new virtual scenes and virtual games that are fun and engaging enough for the toddlers. And you're in the preschool lab as well. We're studying executive functions, for example. And in home lab, we're working on attention.
So you're never going to leave, are you? You're here for the next 25 years. There's so much
Well, this
to
is
do.
like a playground to me, right? With all these
it?
very exciting technologies.
Yeah, and lovely colleagues as well.
Yeah, exactly. So this is a dream for engineers and neuroscientists. So yeah, very lovely place.
Well, thank you very much for everything.
Thank you.
It's really lovely meeting you, Paola.
You too.
Thank you.
Thank you.
Hi. Please, can you introduce yourself?
Sure. I am Natasha Kirkham, and I'm a professor in developmental psychology at Birkbeck.
Wonderful. And here we are. I think we're in the Toddler Lab, but we also have the home lab as well. Are you able to elaborate and tell us a little bit about the home lab?
Sure. So the home lab is the lab that I work out of most of all, and it is a part of the Toddler Lab, which, as you know, is a center that is set up to study all aspects of cognitive development in young children and toddlers. And the home lab is set up to kind of represent and look like an actual front room, sort of a natural front room. And the idea behind most of the Toddler Lab, and definitely behind the home lab, is to make it seem sort of ecologically valid, naturalistic. So the home lab is set up with a sofa and screens and tables and the usual kind of stuff that you might see in a front room. And what it does is it allows us to watch toddlers in a more natural kind of setup. So we could say, for example, have a task that was a concentration task, but we could have a television on in the background and we could have noise around the area. So we could be looking at what distraction looks like. We could be thinking about all different types of distraction, not just auditory noise, but lights going on and off, or maybe something happening off in a window or something. Or have dyads, kids coming in and talking to each other, parents around. So it gives us this way of seeing sort of how the baby works in the wild as opposed to in the lab.
So the idea, can you just expand upon the, you said ecological. So ecological, sort of those of us that don't know about those sorts of things, that is as close to a normal environment as you can possibly get.
Yeah, ecological validity is one of those little catchphrases that we use when we're trying to say it's a naturalistic environment. So when we do lab studies, one of the benefits of a lab study, of course, is you can control every variable. You can have the baby or the toddler doing and seeing exactly the same thing as every other baby and toddler that comes through. You can have the lighting the same, everything the same. And it's very important because it tells us a lot about how the system works in the absence of any other kind of stimulation or input. But for ecological validity, you kind of want to know how the baby or the child works in the real world. It's really excellent to know how the brain is processing information, but what does that mean once they're out in the world, interacting with their family, going to nursery, going to school? So how is their brain dealing with all of the information that's coming in that isn't controlled? And so you can have these kind of setups like this allow us to kind of ask those questions a bit easier.
So earlier I was able to observe one of the toddlers up here, and they had gloves. I know we're sort of surrounded by cameras here, some infrared I believe. They also had a cap on, which I believe is the FNIRS.
FNIRS, yeah.
And do you do a similar sort of thing down in the home lab? Or you're capturing...
Yep.
Well, tell me a little bit about what you're capturing.
Sure. So we can use FNIRS down there as well. We can also just use behavioral. We can use motion capture to see what they're gesturing to, where their heads are moving. So for example, my PhD student, Julia Serino, is doing a study in which she's looking at distraction. So distraction is one of those wonderful words in which we have a real negative connotation that we pin onto it. So teachers, don't get distracted. Parents, don't get distracted, right? But if you're never distracted by anything, then you lose out on some stuff that might be of interest. So it's this idea that you want to be not overly distracted, so you're not focusing, but not so rigidly focused that you're not capturing other elements of your world.
So a little bit of distraction is actually
a good
quite
thing.
important. Okay.
Yeah, sort of right in the middle, right? This sort of nice sweet spot where you can be open to other things. So she's got this lovely study in which she's got kids who come in and they've got 2 screens up because we have 2 big screens in the home lab, and she is asking them to find a hidden dog in a display. And there are some cues that are either...
Might I ask what age we're talking about?
Oh, sorry, yeah, these are 3 to 5 year olds.
Okay.
Little ones,
Right.
toddling. And so during this, there are either distracting noises or there are noises that are cueing them. And so we have a cap on that does some motion tracking to see where they're looking, how distracted they are. We can see where they're moving. They've got a plastic lightsaber that they can use to point, which they like, and all that kind of stuff. So it's engaging and it's fun, but it's giving us all this information because their body's moving the whole time, their head's moving. So it's not just sitting, staring straight, answering.
How are you unpicking all that data? As you say, there seems to be an awful lot of data that's being...
Okay, you may need to come back later and we'll let you know. But yeah, it's going to be extraordinary. It's going to be a lot of, okay, what does that look mean, and can we kind of map that onto exactly what was happening?
You're sounding very excited about
Yes.
this place. I must admit, as I came in, I was absolutely blown away
It's
by
beautiful.
what you'd managed to produce here. But you seem very excited about what you think you're going to be able to produce here.
Yeah, I think primarily because it's allowing us to do stuff we couldn't do before, and it has practical applications, right? So although of course there are always practical applications to understanding the brain and understanding perception and cognition, being able to watch kids walk around in the world. So I don't know if you were shown this before, but you can have this FNIRS cap is now mobile. So they walk around in these little sweet little backpacks, and they can wander around in their environment. And so you have this window into exactly what is happening online.
So as a sort of layperson, you're describing this cap. Is this cap allowing you to see the activity deep in the brain, somewhere in the brain? So you're not looking into the brain, or you sort of are?
No, I mean, it's sort of based on... So there's several ways of sort of looking at how the brain works, and some of the neuroscientific measures allow you to see how quickly stuff happens in the brain, and some allow you to see where. And the ones that allow you to see where are things like fMRI machines, big MRI machines, which you're not going to put little kids into, and also they can't walk around with them. And the EEG nets, which are these little caps you put on, those tell you how quickly the brain is working. And the FNIRS is a really nice system because it sort of does something in the between. So we're getting a little bit of temporal information, a little bit of localization information.
So you are getting brain activity as well that you're recording, as well as all of the sort of visual cues that you're getting.
Exactly, yeah.
And I'm a teacher. So how do you think some of this sort of work might actually become useful, I suppose, relevant? Often teachers do say, so what? So you're here and you're seeing how people move around, so what? Ultimately, I presume you feel that there's some sort of applied ideas that you'll be able to produce from this research.
Yeah, and I mean, I don't blame teachers for saying that, because sort of historically there's been a real gap between the people on the front line, the teachers, and the people behind the computers in the labs, right? And being able to say, oh, look, this is how cognitive development works, is a far cry from explaining how that helps you when little Johnny is throwing his shoe across the room, right? And so I think we're making some really nice headway into dialogues with this sort of the educational neuroscience, sort of really being able to talk about that. I think what's really useful in terms of the kind of stuff we're doing is it's allowing us to see how an actual natural environment is actually affecting some of the stuff we've already been talking about. So we might say, okay, so for the first 5 years of life, we've got this amazing increase in different types of cognitive development, all those executive functions that we love to talk about, working memory, inhibitory control. But what does that actually mean when you're a kid in a classroom and it's noisy? And what does it mean if you're a kid in a classroom and it's noisy, but you come from a house that's noisy or a house that's not noisy? Or what does it mean if you're a kid in a classroom and it's very visually noisy? So there's some wonderful work coming out of Anna Fisher's lab in the States that shows that actually what looks really beautiful in a primary school classroom, having pictures everywhere, can be very
information overload
for certain children. So I think it's about sort of connecting with what the classrooms look like, what the teachers have to do, and then being able to put a little bit of science behind it and say, okay, so you need to work within these realistic circumstances, so let's try and see what individual differences what kind of happen within these kids, and what we can tell you about how to support those children that are struggling with this, or how to support children that are struggling with something else.
So you can mimic a classroom environment, for example,
exactly,
and then see how people behave, and then change the classroom environment, see how people behave.
Exactly.
And that's something that you think you're going to be doing. I presume those are the sorts of studies you're going to be looking at.
Absolutely. So one of the things I'm incredibly interested, and you can probably guess because I keep talking about it, is noise and how noise affects learning. And it's something that became very much more at the forefront of people's thoughts during the lockdown and the pandemic, when suddenly they thought, it's really noisy in my house. I can hear the coffee machine all the time, or I can hear the washing machine. I can't get any work done. And they sort of realized, people became much more attuned to that around. And I think...
But by noise, do you mean literally audio noise, or sometimes these are distractions, visual distractions? In terms of what I've observed at the moment, it looks to me as if what you can do is you can mimic and you can change the sort of environment in a classroom. So, for example, you can have a still, very quiet classroom, measure people's behaviour, and then you can alter things, add noise, add background, I suppose, visual cues and stuff. So... are those the sort of things that you think you'd be able to do with this fantastic new facility?
Yeah, 100%. I mean, we could set up a situation in any of these labs in which we could have all of the speakers around us mimicking what it might be like to live, say, near an airport, or inner city, or, I don't know, rural cows, whatever, that kind of thing, right? And so you could change the auditory environment. We've got screens everywhere. We can change the visual environment. It's a big open space. We can bring people in. We can have kids playing over in the corner while somebody is trying to focus. So we can really make it much closer to what the actual circumstances are like, so that we can investigate how they are learning, how they are thinking. But at the same time, we have control, because we have this wonderful tech, these kits, like the FNIRS. We've got, the motion tracking, all of that kind of stuff. So we're getting real scientific data. It's allowing us to see sort of moment by moment how the kids are thinking and what they're doing.
So you must be incredibly excited about the future. I mean, I don't know how hard you worked to turn this place around, but it looks extraordinarily well equipped, I would say.
Yeah.
Absolutely brand spanking new. You must be incredibly excited about the future. I'm going to say the Toddler Lab. It is the Toddler Lab.
Yeah.
But you can go up to 6-7 years old as well, I assume.
Of course, yeah.
Okay.
Absolutely.
And the future is looking incredibly bright, and you're hoping to be able to continue this research long into the future.
Absolutely. And I think one of the nice things about about this is that when we have students come in and it's already set up, is that we can actually consider doing things like longitudinal studies. You know, we can start out with little ones toddling in at 2 years of age and then follow them 6, 7 years of age and see, okay, how they did in this environment when we tested them at 2. Is that actually playing out? Can we hypothesize from here? Can we predict how they're going to do in a school situation? School readiness is a big phrase, as you know, right? And that's something that people worry about and are concerned about. And there's lots of debate about how ready should children actually be and what does that actually mean. But the bottom line is, regardless where you fall on that particular debate, is that there are going to be some kids who are going to be more, quote unquote, ready for the system as it stands than others. Right.
And having just met you, you come across as a great science communicator. Involvement of staff, teachers in this sort of thing, is it nearly a two-way thing? I wouldn't say two-way, it can't be two-way, but is there any involvement with the sort of teaching profession?
I think that's a really excellent point and question, and it's something that I'm very interested in. A former PhD student, Jessica Massonnier, who's at the University of Portsmouth now, actually did some wonderful work in which she got teachers to help her design her study. So we got noise monitors that we set up in classrooms so that the kids could see how noisy the classroom was, and then we did interventions, different types of interventions, to see what worked best to kind of help reduce the noise and importantly help reduce their irritation of the noise and look at different individual differences with the kids, so who was more irritated than others. And having the teachers on board, and it ended up being a really nice collaborative study, was astonishingly interesting because of course they've got, you know, they're the ones that are saying, well, we can't actually do that because that's not how the classroom works, or actually this classroom is just genuinely more noisy than that classroom, and you have to kind of think these things through. But they had a lot of great insight.
Brilliant.
I think it's silly for us to sit all alone coming up with these ideas, right? We need to actually be out there talking to the people who are, as I said before, on the front lines with these kids.
Well, as a person on the front line, it's been absolutely fascinating coming around the Toddler Lab, and you must be incredibly proud of what you and others have managed to achieve here. It's a wonderful place.
It's great, and we're so happy to be back doing it. You know, we've really been sitting watching this throughout the pandemic and not being able to do anything, and now we're actually people coming in, kids coming in, families coming in. It's wonderful.
Well, congratulations, and
Thanks.
Thank you very much for your time.
Thank you.
Lovely meeting you.
You too.
As a teacher, as a sort of semi-lay person, I don't know, is there going to be a relationship between what you're doing in terms of the academic stuff that you're doing here, be it very sort of inclusive, and what we on the chalk face, I hate that term, but anyway, the chalk face are going to be doing?
Well, I mean, I would hope so. Some of the questions that we would work on. So this is all basic research. But some of the questions we'd be working on, certainly in terms of the preschool lab, should be relatable to issues of early years education, how to best structure child interactions. I talked about the brain synchrony between children that were collaborating, but we can look at that as well with teacher and child interactions. Are there ways of priming the child's attention to get the most effective transmission of knowledge in that age group? And so those are the kinds of questions that we would definitely be exploring as well. So we do work quite closely here with the Center for Educational Neuroscience, of which I am also a member.
Well done.
So, educational questions or questions of educational relevance are at the forefront of what we're thinking about. This is not necessarily true of all the people in this center. Some people are more interested in a kind of more medical angle, looking at atypical development and trying to find ways of supporting children who maybe are not integrating socially as well as others, and when can we detect that and what can we do about it. But certainly my interests and those of most of the people that you actually interviewed today, I think, do have a kind of educational.
Yeah, they definitely do, and
interest.
I'm delighted, absolutely delighted. On behalf of the teaching profession, thank you very much.
Well, great. Well, if it's
is it the world's first?
absolutely.
Really? Wow.
Complete world's first. Nothing like this exists anywhere in the world that we know of. I think it's taken a while to develop, so it's been on the cards for about 4 years. So
you and your colleagues, obviously, at Birkbeck have been working on this for
yes,
over 4 years.
Over 4 years. There's a question of raising the funds, which takes a while, and then
there's a lot of equipment here.
Absolutely,
You've got a lot of stuff.
Yes, and then of course the pandemic arrived and that delays everything and so forth. But since we've started, the idea certainly caught on. So I know of a few individual labs. There's a home lab that's being created in the US and a preschool lab as well with similar sorts of facilities. But we are definitely the only ones with all of it in one building as well.
So the collaboration that you're going to be able to get involved in now, is obviously you've got UCL across the road there, but we're talking international, we're talking, you have already got people phoning you saying, Denis, what happens? How do you do this? Should we do one? Why don't we do one in
The short answer is yes. I mean, fortunately, we already had quite a lot of international visibility.
Right.
So even prior to the Toddler Lab, the Baby Lab was really at the forefront of developing technologies and protocols for assessing learning in young babies. So people were already knocking at the door saying, ooh, how do you do this? Can you show us how to set up a lab like that? This is just continuing basically what we've been doing in terms of kind of leveraging technological innovations to get better answers at the kind of questions of cognition, learning, and development that we were interested in. So yes, people are knocking at the door. We have to, ultimately the aim here is to help us understand children's learning and, identify practical applications of this in education and in other domains. So we have to be a bit careful about balancing the time to share our knowledge in terms of dissemination and actually doing the research.
Absolutely.
Because at some point, it's not just for show. It needs to be utilized.
Well, you can definitely get a sense it is definitely not for show. I mean, this is definitely, I'm going to use the word lab. You are using the word lab.
Absolutely.
It's a very, very inclusive and very friendly lab, but it's nonetheless a lab. I'm getting the impression it's going to be a 7 days a week sort of facility. You're going to have people wanting to use it. Anyone involved in any developmental psychology, any cognitive psychology stuff, I presume, are going to want to come in here and say, Denis, can we use it for, certainly you're going to be, I don't know, taking bookings.
Yes, well, exactly, we do. Yes, we will do. We do have actually some, we do have some guidelines. So it's some of it is open for external use as well. So we do have a procedure and guidelines for people who would like to use these facilities when it is free. But just in terms of the kind of 7 day a week thing, we often do operate on the weekends because preschool children, nursery school children are at school
during the nursery, funnily enough.
Funnily enough, yes. So the parents, bring them in on the weekends, school holidays, and so on. One of the projects we have lined up in not this year, but in about 18 months' time, is to actually be running some Saturday clubs in our preschool lab, where we would have, real children committing to a term. They would come on a regular basis and be involved in lessons, support lessons in whatever the curriculum, whatever is essential for the curriculum in their year group at that time, and kind of sneaking in our studies in the middle of this kind of real world things, because this is really about getting to how does learning happen in the real world without quite going out in the real world, because the real world is even messier than this.
So you're taking out as many variables as possible, but it's not quite as noisy or as messy as it is out there in the real world. Right. So in sort of summary, direction of travel here, I mean, you have alluded to all sorts of things that you're doing, but is there a final fundamental thing that you can sort of see in 10 years' time, 15 years' time, or is this now the next 50 years? This place is going to be around for an awful long time.
I don't think we have a final target destination. I think it was more of a kind of setting the groundwork to allow us to ask certain types of questions. So those questions are, we've done very well at understanding brain and cognitive development in these kind of rigid lab-based studies, and controlling all the variables and making sure the children were focused on the task and so forth. And one of the challenges we've had is trying to translate those into applicable lessons for the classroom, for example. And in trying to do that, what we've observed is, of course, some of the lessons we've drawn in the lab don't really apply in the classroom because it's not the way children are learning in the classroom, right? So this is now going to allow us to look at learning in groups with peers. So that's basically, I think, the big picture, as it were. And then all kinds of different sub-questions can be plugged into that.
You must be very, very proud of this place. It's an amazing facility. As I say, I've been incredibly impressed.
Well, I mean, we are very proud. We're proud of all the people who put the work into designing it as well. We're very grateful for the people who gave money to to fund it. And yes, we're looking forward to using it, to changing the way people understand how young children learn, and particularly how the impact of peer relations and interactions affects the developing child's brain.
Well, I have to say, on behalf of Learnus, thank you very much for allowing us to come here, and thank your colleagues at Birkbeck and whoever else has been involved in this on our behalf. It's been, as I say,
Great. Well,
fascinating,
thank you.
really interesting.
Yeah, it's always a pleasure working with Learnus.
Oh, thank you very much. Thank you.